Welcome to my YouTube channel. If you've not subscribed, please subscribe for more content weekly. So today we are going to solve Pure Mathematics 1, October-November, variant 1-3. So we have question 1, and question 1, what does it require us to do? It wants us to find the equation of the curve where we are given the dy dx. We have a differentiated expression and we need to get the original curve. So what we do, we integrate, because integration is the reverse of differentiation. So for us to be able to find the y, which is the equation of the curve, we are going to integrate. So finding y is basically you integrating x minus 3x power negative a half dx. So whenever we are integrating, we increase the power by 1 and divide by the new power. So we shall have x squared over 2. Then here we shall have 3x power half. We increase the power by 1 and divide by the new power, which will be a half. Then plus a c. If I'm to write it, I will end up having my y, which is x squared over 2 minus 6 root of x plus c. So how to get the constant of integration? We are given a point. This point lies on the curve. So if it lies, it satisfies. So we are going to substitute this very coordinate in this equation of our curve. So we shall have 1 equaling to 4 squared over 2, which is going to be 16 divided by 2, which is 8. And then minus 6 times root of 4, which is 2, so minus 12, then plus c, going to be negative 4, so we shall end up having a 5 equaling to c. So I've gotten my c, so this implies that my equation of the curve is y equaling to x squared over 2, then minus 6 root of x, then plus 5. And whenever you try to differentiate this kind of expression, you end up having the dy dx that was in the question. That was question 1. It was about integration. So we go to question 2. Question 2 is about coordinate geometry. We have an equation of the circle and we are told it is intersecting the y-axis, which is the line x equaling to 0. So and whenever we solve simultaneously, we get the point of intersection. So we have a circle intersecting with the y-axis and we want those points of intersection. And basically the question requires us to just get the y coordinates, because the x is basically 0. So I'm just going to substitute x as 0 in my equation of the circle, and I end up having 0 minus 3 squared plus y minus 5 squared equaling to 40. So this is going to be 9 plus y minus 5 squared equaling to 40. Take 9 on the right, you end up having y minus 5 squared equaling to 31. If you want to find y, you take a root both sides. So this, I end up having my y, which is equal to 5 plus or minus, because whenever you take a root of anything, you end up having plus or minus. So meaning the y coordinates, either if I'm taking a positive one, is 5 plus root of 31, and another y coordinate will be 5 minus root of 31. Then we go to part B of the question. Part B says to find the equation of the circle if which has A and B as the diameter. So if this is my A and this is my B, then to get the center, I'll have to do midpoint, and to get the radius, I get the distance between the center and any point. So now I already know my coordinates of A. If I assume A is taking on the negative one, which was 5 minus root of 31, and then the B would be 0 and 5 plus root of 31. So if I'm to get the C, it is basically the midpoint. So I will get the 0 plus 0 divided by 2, then 5 minus root of 31 plus 5 plus root of 31 divide by 2. So I end up having 0, 31, root of 31 goes, I end up having 10 divided by 2, which is 5. So this is my midpoint, which is the center. So now I need to get the distance between the center and any point, and basically let me take this one here. Okay, so how do we get that distance squared? You get the x's, subtract them, squared. Get the y's, subtract them. Then squared. So you end up having your r squared equaling to, this is going to be 0. When I open brackets here, I will end up having 5 minus 5, which is 0, root of 31 squared, which is simply 31. So meaning if I'm to write an equation of the circle, it will be very easy. I'll just say x minus 0 squared plus y minus 5 squared equaling to 31. So that's for that one. If you don't want to include the 0, you could just basically say x squared plus y minus 5 squared equaling to 31. That's for B. And then we go to number 3 of the question. Number 3 is about trigonometry, and it is basically we showing that this expression here can be as well written in that form. So what you have to do, you need to convert the tan. So we shall end up having 5 cos theta minus sin theta. Tan is simply sin theta over cos theta. Then plus 1 equaling to 0. If I don't want the cos theta here, I can multiply it on each and every term. I multiply it here. I can multiply it even on this one here, and also on this one here. On the right hand side, basically it will be a 0. So I end up having my 5 cos squared theta. This cos will go with that, minus sin squared theta plus cos theta equaling to 0. So you could, we have to express sin squared theta in terms of cos. So we shall have 5 cos squared theta minus 1 minus cos squared theta, then plus cos theta equaling to 0. So I end up having 5 cos squared theta minus 1 plus cos squared theta plus cos theta equaling to 0. So if you're to collect like terms together, you end up having 6 cos squared theta plus cos theta minus 1 equaling to 0, and you've expressed it in the form that they want. So that so question 3, it was about trigonometry. So part B says hence solve. So we begin from where we stopped from. So the whole of this expression is equal to that. So when it comes to solving, I will be solving 6 cos squared theta plus cos theta minus 1 equaling to 0. So this is a quadratic expression, but in terms of the cos's, not x. So meaning when I solve it, I'll have cos theta equaling to negative a half, and cos theta, when you solve with the calculator, please use a calculator. When you use a calculator, make your a to be 6, your b to be 1, and your c to be negative 1, and the answers you get will be negative a half. And so I need to show the method, and the easier way is you work backward. Cross multiply, we shall have 2 cos theta plus 1, and then here we shall have 3 cos theta minus 1. So this is the method that I have used of factorization. But if you had gotten decimals that can't be written as that can be written as fractions, the best method you'd have used would have been a quadratic formula. So when you reach here, you need to solve. But remember, our answers are required to be in radians. So I request you take cos inverse. So theta will be cos inverse over half. I want you to get the cos inverse over half so that you get that acute angle. Because when you take cos inverse of negative half, it will take you in the second quadrant. So it means that this angle that I've gotten will be for here. This is the cos inverse over half. But remember, all scientists take chemistry. The answer I'm supposed to give should be in the quadrant where cos is a negative. So it should be in this quadrant and in that quadrant. Meaning, the answer that I should give should be pi minus, because the angle here in the second quadrant is pi minus cos inverse over half. So get your calculator and you get the answer. And make sure, please, you leave it in your calculator is in radians. So my calculator is giving me that. Then another angle will be this one here, which will be pi plus cos inverse plus this acute angle that you got. So another angle is going to be pi plus cos inverse over half, which is going to be 4.189. This was for cos theta being negative a half. So if I'm to go to cos theta being a third, theta is cos inverse of a third. And when you do that, you end up having theta as 1.23. So this is the angle in the first quadrant. But remember, we are looking at where cos is positive, meaning another angle will be in the cos, which is going to be 2 pi minus that acute angle you got. So another angle is going to be 2 pi minus 1.23, which is 5.05. So meaning your angles, actually we have now 2.094, 4.189, 1.23, and 5.05 as our angles. So this question was, it was about trigonometry. We go to the next question. So the next question is about series and binomial expansions. So we are going to expand this. So all you have to know is that 1 starts with the power of 5, while 2x starts with the power of 0. Then the 1, the power reduces, becomes 4, while for 2x, the power becomes 1. And then next, 1 attains the power of 3, and 2x attains the power of 2. Even if I stop here, because the question says I expand up to x squared. So I'm going to put in the coefficients. This is 5 combination 0. This is 5, 0, 5, 1, and this is 5, 5, 2. So you have to multiply carefully so that you're able to get the right answer. So this is going to be 5 combinations 0 is 1, then times 1 times 1, then plus 5 combination 1, which is 5 times 1 times 2x. Then the next sum, 5 combination 2, which is 10 times 1 times, you have to know your indices properly. This is going to be 4x squared. So my final answer is 1 plus 10x plus 40x squared. Then next, we are going to expand this still, expanding up to the term x squared. So you have to know that 1 will start with the power of 6, while negative ax, you take it with its operation, will have the power of 0. The next term, 1 becomes 5, while negative ax attains the power of 1. The next term, 1 will become 4, and negative ax attains the power of 2. You need to be very careful. So when you're carrying the b, which is negative, you carry it with its operation. Don't just take it as ax. So next I put combination 6, 0, 6, 1, and then 6, 6, 2. So the whole of this is going to be 1. The whole of here, then this is 6 formation 1, which is 6, then times 1 times negative x plus 6 combination 2 on a calculator, it gives 5, then times 1. If you remember indices properly, this negative will end up being positive, then times a squared x squared. So the final answer should be 1 minus 6x plus 15 a squared x squared. So yeah, so it was as easy as that. So we go to the next one. They are saying the expansion, in the expansion of this times that, the coefficient of x squared is -5. So you need to be very careful. We already expanded 1 plus 2x power 5, and the expression we got was 1 plus 10x, then plus 40 x squared. And then in the other expansion of 1 minus x squared, we got that, which is simply 1 minus 6x plus 15 a squared x squared. So we are interested in the coefficient of x squared, and we are told the coefficient of x squared in this expansion is -5. So how do we multiply? Remember how we will multiply double bracket. This one will multiply, for you to have an x squared, then this one must multiply with 15. 15a squared x squared. Then 10x, it should multiply with -6ax, so that we have x squared. Then the 40x squared, because it already has an x squared, it should multiply with the 1 in the second bracket. You don't have to expand everything, just focus on each term and how you can get an x squared. So meaning 1 multiplies with whatever has an x squared already. Then 10x will multiply with what has 1x. Then 40x squared should multiply with, so that at the end of it all you have your x squared. So here we shall end up having 15 s squared x squared minus 6c a x squared, then plus 40 x squared, we are told, is equal to -5 x squared. So I'm going to pull out x squared. So I will have 15 a squared minus 6c a, and then plus 40, then x squared, and this is equal to -5 x squared. So what you do, we compare. So we compare, meaning 15 a squared minus 6ca plus 40 is equal to -5. I'm saying we are forming a quadratic expression. So we shall say 15 a squared minus 6ca plus 45 is equal to 0. This kind of a quadratic expression can be reduced by dividing by 15, so that I have a squared minus 4a, then plus 3. So when you solve this on a calculator, making your a to be 1, your b to be -4, and your c to be 3, you end up having your answer as 1 and your answer as 3. So you need to work backwards to give the formula. So working backward only works with the factorization method. So meaning a is either 1 and a is 3, and that's what the question wanted. It wanted the possible values of a. So this question was about binomial expansion. So we go to the next question, and this question was about series. It was about sequences. So usually I combine series and sequences, because after series you go to sequences. So this is about sequences. So we are told that the first and second and third were geometric. So you need to know what is special about the geometric. It is that the common ratio is the same. How do we get the common ratio? We get next divide by previous. So meaning how we get the common ratio, I'll say 5p over 2p plus 6. And then also next divide by previous. So I'll say 8p plus 2 over 5p. So that's how we get the common ratio. But remember, the common ratio is supposed to be the same. So equate these two and form an equation. So I am going to equate them. So I'll have 5p, because the common ratio is supposed to be the same, then equaling to 8p plus 2 over 5p. You cross multiply, we end up having 5p times 5p, which is 25p squared, 25p squared, equaling to 8p times 2p, that is 16p squared, 8p times 6, which is 48p, 2 times 2p, which is simply 4p, 2 times 6, which is 12. So when you're to put everything on the left hand side, we shall end up having 9p squared minus, so when you add this together and take to the left, minus 52p, then minus 12, equaling to 0. So what you do here, you work it out with a calculator. It is easier, and you get your whole numbers, and then you get a fraction, and then you can work backward. So we shall say p minus 6, and then for here we shall have 9p plus 2 to show that you used factorization. So the next one, they are saying the one where they're saying for the value where p is a negative, use this value of p to find sum to infinity. How do we get sum to infinity? Simply first sum over 1 minus r. So how do we get the first term? The first term, it was 2p plus 6. We already got our p, so which is a negative 2 out of 9, because they said we take a negative, then plus 6, and you end up having your answer. So you end up having your answer as 50 out of 9. Then we need to get the common ratio. So we had our first term as 2p, second term as 5p, and then the third term as 8p plus 2. So how do we get the common ratio? Next, divide by previous. So, and here if you have 5 times p, so meaning the first term, which is u1, then the second term, we shall have 5 times negative 2 over 9, which is simply negative 10 over 9. So I can easily get the common ratio, which is next, divide by previous. So when I divide by 50 out of 9, I'll end up having negative 10 out of 9 times 9 out of 50, and I get my common ratio as negative 1 out of 5. So I know my first sum, I know my common ratio, so all I have to do is substitute in the formula for sum to infinity. So I'll say 50 out of 9, then I'm dividing by 1 minus negative 5, which is simply 1 plus 1 out of 5. This is going to be 50 out of 9, and I'm dividing by 6 out of 5, and I'll end up having 50 times 5 over 9 times 6, and I'll end up having 250 over 54. You can go ahead and reduce it, or you can just leave it like where I've left it, and that's the sum to infinity. Always make sure that you leave it in fractions, not in decimals, because we know sum to infinity, it is converging to a certain point. So we go to question 6. Question 6 is about quadratics. So we are told that a line and a curve intersect at one point. So they want us to find the values of C and then the corresponding value of P. So what we do, we begin by solving simultaneously. So they are all equal to Y, so I equate them. So I need to use the discriminant of tangent, which is b squared minus 4s equal to 0, but I can't use it before I form a quadratic expression. So I have to first form a quadratic expression. So yeah, take this side, 2x minus 6x, we end up having 4x, then plus c minus 3 So this is something quadratic. So I'm going to say b squared minus 4ac is equal to 0. And we see clearly the b is negative 4 squared, then minus 4 times c times c minus 3 equaling to 0. So this is going to be 16 minus 4c squared, then plus 12c equaling to 0. So to form something quadratic properly, I could take everything to the right. So I have 4c squared minus 12c, then plus minus 16 equaling to 0. So this can be reduced by dividing by 4. So I will have c squared minus 3c minus 4 equaling to 0. Solve. So when you solve, you get c as negative 1 and c as 4. So when I work backward, I'll have c plus 1, because you have to show a method, and c minus 4 equaling to 0. So I have gotten the c. So meaning I can come back and substitute here so that I can solve the quadratic expression with, so for c equaling to negative 1, I'll end up forming this kind of a quadratic expression when I substitute c. So for every c, you come back and solve a quadratic equation to get the coordinate of p. So when c is negative 1, I will end up having minus x squared minus 4x and then minus 4. I could divide by and negative both sides, so I end up having x squared plus 4x plus 4 equaling to 0. When you solve this with the calculator, it only brings 1x. The calculator brings 1x, which is negative 2, which tells you that actually this is a repeated root. So you work backward twice because it is a repeated root. So when x is negative 2, then how do you get y? You come back and substitute. So here we took the c to be negative 1, meaning our y is 6x plus 1. So when you make your x to be negative 2, you end up having your y as negative 11. So meaning one possible value of p is negative 2, negative 11. That was for c equaling to negative 1. So meaning another c, I do the same. So for this c, I also substitute and get another quadratic, equation and solve it. So when c is 4, we shall end up having 4x squared minus 4x, then plus 1 equaling to 0. When you solve this one with the calculator, it gives you the answer as a half, meaning it only brings x as 1. So it means that, yeah, it is a repeated root. So I work backward twice. So cross multiply, take the 1 to the left, and you do the same here. So, and the good thing, they told us that the line is a tangent. That's why basically we are getting a repeated root, that when you solve it, you only get. So meaning when your x is a half, go back and substitute in any. The line is easier, so you end up having your answer as negative 1. So we shall end up having a half and negative 1 as another possible coordinate for p. So you need to solve simultaneously, form something quadratic, use a discriminant, and get the possible values of c that give us a repeated root. So for one, solve, for another one, solve, and those are the answers that you'd get. And it was taking seven marks, quite a lot of marks. So we go to the next one, which is question 5. It's about see, question 7. Oh, question 7 is about functions. Question 7 is about functions. So the function is defined for that. So they want us to find the range. So according to the domain, we have x greater than 2, meaning if I'm to formulate the domain, it would be 2 to infinity, right? So when you make your b 2, when you make your x be 2, when you make your x to be 2 in this very expression. So I'm going to put 2 and infinity. So when I put 2, this is the lower limit, this is the upper limit. So when I put 2, I end up having 1, 3 over 0, which is basically infinity. Yeah, it is infinity. So when I put 2, I get infinity. Because if you have 1 plus infinity, you get infinity. Then when I put infinity, so when I put infinity, I'll end up having 1 plus 3 over infinity minus 2. So if you have something very big on the denominator, then this expression here will tend to a 0. Because if you have 3 over something really, really big, you'll get an answer like 0.000. So we say that it tends to infinity. So meaning I will end up having my f infinity being 1. So if it means my range is 1 up to infinity. So in short, it means my fx is greater than 1. So then part 2 says we find the expression for f inverse. So you will let our expression fx to be y. So our fx was 1 plus 3 over x minus 2. So what I do, I'm going to make x a subject, but before I make x a subject, I'll cross multiply and I'll take 1 to the left and end up having 3 over x minus 2. So what I do next, because I need to make x a subject, I'm going to cross multiply and I'll end up having y minus 1 and then x minus 2 equaling to 3. I need to make x a subject. I could divide by y minus 1. I divide by y minus 1 and end up having a x minus 2 equaling to 3 over y minus 1, and I take x to the right, 2 to the right, I end up having 2 plus 3 over y minus 1. And from this kind of expression, f inverse of y is equal to x, meaning f inverse of y is equal to x, and the x is 2 plus 3 out of y minus 1. So meaning f inverse of x is wherever there is y, I'll put x. So there are 4 steps. I wouldn't want you to start interchanging. That is not A-level maths. So there are 4 steps. 1, you let fx to be y. Then next, make x the subject. Make x the subject. Then from step 1, it means f inverse of y is equal to the x you got, and from there you can easily so if you have if from here, if f inverse of y is equal to x and you got your x as that, you substitute it, meaning f inverse of x, like you have to make sure that one step leads to the other. In A level, don't say interchange, make y the subject. No, make sure that one step leads to the other, So this is our expression for f inverse. So remember, if I have my function and has coordinate x, y, if I come to the f inverse, it means the y becomes the x and the x becomes the y. It's like you're switching. So if in part 1 I got the range, that range is the same as the domain for my f inverse. So where they ask us for the domain of f inverse, I will say x is greater than 1. The range of the function is the domain for the f inverse. We go to part C. What does part C require us to do? We need to get the expression of g f of x. So you go in the expression of g is the first function, write it, but wherever there is an x, leave a bracket. In the bracket, come and put So you write the expression of the first inverse, which is 2x minus 2. But instead of writing x, you put the expression of f, which is 1 plus 3 over x minus 2. When you enter the 2, we shall end up having 2 plus 6 over x minus 2 minus 2. The 2, you can see clearly that they give you a 0 and you end up having your answer as 6 over x minus 2 as your g f of x. All right, so we go to question 8. Question 8 we're on transformations here, transformations of function. So we are told the diagram shows part of the graph where a and b are positive constants, the values of a and one value, possible value of b. So now this is a sine graph that was stretched, we see horizontally. It was stretched and shifted, just in the horizontal according to these transformations. If you're to compare with the one of sine equaling to y equaling to sine x, you see that all the transformations are horizontal transformations. They are all horizontal transformations. So you need to now relate it to the sine. If you remember how to draw the sine curve, so sine 0, sine 90 is 1, sine of 180 is 0, sine of 270 is -1. So it was supposed to be, this is pi, then pi out of 2 is here. So the sine graph is supposed to have been like this, because sine 90, so we are on 0, so when you come to sine 90 we are there, and then 180 we are on so I'm saying 108. Oh, so this is 90, yes, and then 180 we're supposed to be there, right? Okay, 2 pi is there, so meaning, yeah, it was supposed to continue like that. So okay, now just that small sketch, just that bit, upper amplitude of sine, can easily get me what I want. So you can see clearly that there was a stretch horizontally. If I want to get a, there is a horizontal stretch. So you can see up, just looking at this upper curve that is above the x-axis. On an original sine curve, it is supposed to cover how many boxes? It's supposed to cover 1, 2, 3, right? 3. But then when you look at what we have, it is 1, 2, 3, 4, 5, 6. So meaning it is a stretch factor of 2, parallel 2. So it was supposed to be 2 originally on the sine, but we are seeing now it was supposed to be 3, right? 3 boxes. 1, 2, 3. It was supposed to be 3 boxes, but we see there are 6. So we see that 3 is being multiplied by 2, meaning it is a stretch factor of 2, parallel to the x-axis. And remember, transformations along the x-axis, we do the reciprocal, meaning a is simply a half, because it's a stretch factor of 2 parallel to the x-axis. Then also when you come to the sine graph, it is supposed to pass through 0. It is supposed to pass through 0, but according to our graph, instead it is behind. Instead of 0, it is on negative, yeah, pi out of 3. So meaning it shifted to the left. Can I say shifted to the left by pi out of 3, meaning the b is simply pi out of 3. Yeah, that's it. Then when I come to another one, another question, another curve has a stationary point of P and Q. So we are seeing that kind of stationary point which is on a original curve, there was this kind of transformation. So I'm seeing -3, but look at it, -3, it means it is stretch factor. When you look at that 3, there's a stretch factor of 3 parallel to the y-axis, because this is the x, this is the y. This transformation here and this transformation here, the a quarter and 8 only affect the x coordinate. So if I want the y coordinate, I look at the stretch factor of -3. So meaning the y coordinate, there's a stretch factor of -3 parallel to the y-axis, will end up becoming -3q. Then when I come to the x coordinate is affected by the 2 horizontal transformation. X coordinate, it is affected by a quarter, and remember on a quarter, if it is a stretch on the x-axis, it means if you're to write a coordinate, it is multiplying by 4. It is a stretch factor. A quarter on the x-axis, we describe it as a stretch factor of 4, meaning the coordinate of P will multiply by 4, and then we also see that this +8, it means it moved to the left, which is -8. So meaning if I'm to write the coordinates of the stationary point, it is x, which is 4p minus 8, and then the y is -3q. So you needed to know the transformations properly for you to be able to work out that. So here we are told, question 9, we are asked the equation of the normal. So we are looking for the equation of the normal. A normal is a straight line, meaning it is in the form of y equaling to mx plus c, where the m is the gradient, and the c, we shall be able to get it because we have a point. But how do we get the gradient? When it comes to curve, we differentiate, and whenever you differentiate, remember how we differentiate, dy dx, we shall drop the power and reduce the power by 1. So I will drop the power, then reduce the power by 1. The constant becomes 0, meaning my dy dx is basically 1 out of root of x. And I'll end up having to substitute the gradient, and I end up having a half. So this is my gradient of the curve, which is the same as the gradient of the tangent. So if I want the gradient of the normal, I'll say negative reciprocal, which will be -2. So if you have a point and the gradient, then we substitute in this form. So I can call this one x1 and this one y1. So I'll say y minus 3 is equal to m, which is -2, x minus 4. Simply y equaling to -2x plus 8 plus 3, and I end up having y, which is -2x plus 11. So that is the equation of the normal. So you must first get the gradient of the tangent, and that to get the gradient of the normal, you should know the product is -1, and shortcut we do negative reciprocal. And then yeah, you get that, you substitute, and then you get your answer. So see, on differentiation, we are told that the point is moving along the curve in such a way that the x coordinate is increasing. So they have given us dx dt as 3. So the question says find the rate of increase of y. We are looking for dy dt. So you should be able to form the chain of dy. It means here I have dt. So another variable I should have is dx and dx. So do I have dy dx at the point A? Yes, I have it. And up it was 1 over root of x, which is simply a half. So times 3, and you get your answer at 3 out of 2. So that is my dy dt. So the point there was you being able to find them, you being able to get be able to formulate the chain rule and then substitute. Then it goes ahead and says at the point at A, the moving point suddenly changes direction and speed and moves down the normal in such a way that the y is decreasing. So meaning dy dt is -5. It is decreasing. If it was increasing, we would have left it positive. So the question says find the rate of change of x coordinate. So dx dt. So if you're able to formulate the chain, it means we have the x here. Then we have dt here, meaning another variable is dy, because you can see that it closes out. But what is my dy? What is my dx dy? Look at your normal. The gradient of the normal is actually, we had gotten it as -2. The gradient of the normal up, in part 1, it was, so the dy x of the normal, dy x was -2, meaning the x dy is just you doing the reciprocal, which is -1/2. So I come here and I substitute -1/2 times -5 and get my answer as 5 out of 2. So it was like that. We got our second last question, and the second last question, it was about circular measure. So we want it is very important that you read this information here. We are seeing the diagram shows points A, B, and C lying on a circle with center O and the radius R. So this is R, even this is R. Then angle AOB is 2.8 radians. The shaded region is bound by 2 arcs. You can see clearly. The upper arc is part of the circle with center O and radius R. The upper one is from the original circle, and the lower arc is part of the circle with center being C and the radius being R. So they want us to find the angle ACO. So we need this angle here. So here, if I'm to take you back to circle properties, the angle subtended by the arc subtends at the center is twice the angle at the circumference, meaning the whole of this angle is actually 2.8 divided by 2, which is simply 1.4, meaning all of this angle is 1.4, making this one here to be 0.7, meaning angle ACO is 0.7 rad. So there was no working for that. You all needed to use the circle theorems, that the angle that the arc subtends at the center is 2 times the angle it makes at the circumference, and you'll be able to get that rightly. So they're saying find r in terms of small r. So if I'm to take you back, so we need to find r in terms of small r. If you're to look at this kind of triangle, even this one is r, making this angle also to be 0.7, because it will be an isosceles triangle. So this is a right angle triangle. So this one here is r out of 2. Even this distance is r out of 2. So I can use trig ratios to be able to express bigger r in terms of smaller r. So if I'm to use cos, because I have adjacent and hypotenuse, so I'll say cos. This working is on part B, please. Cos 0.7 is equal to adjacent, which is r out of 2, divided by the hypotenuse, which is r. So cos 0.7, so this is going to be cos 0.7 equaling to r over 2r. So meaning I'll cross multiply and have big R equaling to 2 times cos 0.7 small r, and you get your R being 1.53 r. You make sure that your calculator is in radians. This was part of, this was the working for part B, but I wanted to keep, you know, like looking at the diagram. So lastly on that question, they wanted the area of the shaded region, and it took 7 marks. Okay, so if I'm to do a sketch right here, this is the original circle. My art isn't really good. 0.28. Then I also have another circle and a sector that has a center right here. And yeah, so this is the area of the shaded region that they want us to find. So this is big R, then this is big R, and this is small r, r, r. So we are required to find the area of the shaded region. So what you need to do is you need to find the area of the major segment. When I consider a bigger circle, I need to get area of a bigger segment. I need to get area of bigger segment. So when I get area bigger segment, I'll be getting the whole of this area of bigger segment minus area of smaller segment. So now I want you to look clearly. When I get area of a bigger segment, I am getting this area here. Area of a bigger segment. I'm trying to highlight it. She's misbehaving. So this is area of a bigger segment, and then I will subtract area of a smaller segment. And a smaller segment in this case is this one here. But how do I get area of the bigger segment? It means I'll get area of a sector, this sector here, from the original circle, and I subtract the area of a triangle. Yeah, so if I get I'll get the whole area of a sector, which is this one here in green, and I subtract the area of this triangle here, and I'll keep with the other big circle. So I'll say it is area of a bigger segment, which is a half r squared theta. R squared theta minus, and the theta in that case is 2.8. And I'm subtracting the area of a triangle. If you have two sides known and an angle, we say a half AB sine C. So a half r squared sine 2.8. Then minus area of a smaller segment. The smaller segment is this one here. So how do I get the area of that small segment? It is simply the area of this whole sector, which is a half r squared. But remember the r in terms of small r, we got it as 1.3 squared r squared, because remember you square it, because it is a half r squared theta, and the theta that we shall use will be 1.4 minus the area of a triangle, which is going to be a half AB sine C, and the AB is 1.53 r squared sine over 1.4. So if you do that, I can, for only here alone, I can pull out r squared over 2, and we'll have 2.8 minus sine 2.8, which will give me 2.465. Then minus, even here I do the same. I can pull out 1.53 squared r squared over 2, and I say with 1.4 minus sine 1.4, you measure your calculator is in radians, and you will have 0.4146, 0.4146, yeah. So the r squared is common on either side over 2, so I end up having r squared over 2, and I'll have 2.465. When you work it out, then minus, you multiply 1.53 squared times 0.4146, because the 2 on the denominator you already worked it out. So 1.5, you already pulled it out, times 0.4146. We shall have r squared over 2. Use your calculator properly. You end up having 1.4945, and you have your answer as 0.747 r squared as your area of the shaded region. So you needed to look at your diagram properly and be able to get the area of a bigger segment minus area of a smaller segment. So we go to the next question, and which is the last one. It wants us to find the coordinates of r, and we are told that r is the stationary point. So how do we get coordinates of the stationary point? We differentiate and equate to 0. So we have y equaling to x plus 2 into x into, when you into 2x minus 1. We never differentiate in the denominator. So my dy dx is equal to, here it will be 1. Here you drop the power, reduce the power by 1. So it will be minus 4, reduce the power by 1, times when you differentiate what is inside the bracket. So it is a reverse of chain rule that you would do. So you end up having 1 minus 8 over 2x minus 1 cubed. So this is my dy dx. But remember, at the point of turning, your dy dx is equal to 0. So I'll say 1 minus 8 out of 2x minus 1 cubed is equal to 0. So what I do, I'm going to take this expression to the right, so that I have 1 equaling to 8 over 2x minus 1 cubed. When you cross multiply, you'll end up having 1 times 2x minus 1 cubed, which is 2x minus 1 cubed, equaling to 8. You take a cube root both sides. So you end up having 2x minus 1 equaling to 2. Cube root of 8 is 2, so I'll have 2x equaling to 3, and x as 3 out of 2. So we've gotten that. So we need to find the value of y. So when x is 3 out of 2, what is y? So you come and substitute in the original equation, which was x plus 2 over 2x minus 1 squared. So if you make your y to be, your x to be 3 out of 2, shall have that over, this is 3 out of 2, the 2 cancels, you keep a 3, 3 minus 1, which is 2, 2 squared, which is 4, and you end up having this will be a half, so which is going to be 4 out of 2 when you add it up together, and you get your y as 2, meaning the y coordinate of r is 2. Then the next one, which is most likely our last question wants us to find the area of the shaded region. So how do we get the area of the shaded region? It is the area of the trapezium minus the area under a curve. So you needed to first get P and Q, the coordinates of P and Q, and so that you are able to get the area of a trapezium, and getting the area under the curve, we integrate. So you need to know that P actually is 1y, and then Q is simply 2y, because they all lie on a curve, so they satisfy. So if you wanted to get coordinate of P, you'd substitute in this kind of expression, you put your x to be 1. So when you put 1, you will end up having y equaling to 1 plus 2 over 2, 1, which is simply 3, meaning the coordinate here is of P is 1, 3. So the coordinate of P is 1, 3. So here it is 1, 3 for P. Then if you wanted the coordinates of Q, then you substitute, and wherever there is x, you put 2, so you end up having y equaling to 2 plus 2 over 4 minus 1, which is 3, which is 9. And when you work it out, you end up having your answer as 20 over 9. So meaning here the coordinate is 2, then 20 over 9. So if you wanted to get the area of the trapezium, it is simply a half height. The height is 2 minus 1, which is 1, and then this distance, which is 3, plus this distance, which is 20 over 9. So you get this distance here, and the distance from here to here down is 3, and the distance from here down is 20 over 9. So all this kind of working is supposed to be on part B. So I'm going to say shaded region is area of a trapezium minus area under curve. Shaded region is area of trapezium minus area under a curve. Area under curve. So how do we get area of trapezium? It is a half height, which was 1, then a plus b, 3 plus 20 over 9. So this is going to be a half. Here we have 27, which is going to be 47 out of 9. So area of a trapezium is simply 47 out of 18. Then area under curve. How do we get area under curve? We integrate. So we shall integrate from 1 to 2 of the curve, which was x, plus, we never integrate in the denominator, then dx. So you integrate, we shall have, this is area under curve. So we increase the power by 1 divided by the new power. We do the reverse of chain rule. Here we increase the power by 1. We divide by the new power times when you differentiate inside the bracket, and then we use our limits 1 to 1 to 2. So when you do that, then you'll be able to, after integrating, you'll be able to see this and this are closing out. So basically it is x squared over 2, then minus 1 out of 2x minus 1. So I'm going to put in my limits. So put in a 2 first. So when you put in a 2, we shall end up having 4 divided by 2, which is 2, minus, when you put in a 2 here, we shall end up having 2, which is going to be 4 minus a third. 2 minus a third. Then we are subtracting. When you put in a lower limit, which is going to be a half, and when you put a 1, you shall end up having, 1 over, over 1, so minus 1. Yeah, so you end up having your answer as here. When you work it out, you can even work it out with a calculator, and you get your final answer as 13 out of 6. So the real area under a curve would be area of a trapezium, which is 47 out of 18 minus 13 out of 6. So when you work it out, you could consider looking for the LCM or use a calculator to work it out. And the LCM is actually 18, then 47, 3, that is going to be, 39, and you end up having your answer as 8 over 18, which is 4 over 9 as our area of the shaded region. So that was all about October-November variant 1-3 pure mathematics. If you've not subscribed, please subscribe, for much and more.